Okay, man.
This live event will begin in 19 minutes. Tab in a Chrome web.
അച്ഛനെ കാണുന്നുണ്ടോ? അച്ഛനെ കാണുന്നുണ്ടോ? ഓക്കെ, അച്ഛനെ കാണുന്നുണ്ടോ? ബ്ലാങ്ക് സ്ക്രീനാണ്. ആ ആ എന്തോ വന്നിട്ടില്ലേ മീറ്റ്? ഗൂഗിൾ കലണ്ടറോ? ആ ടാബ്. ഓക്കെ ഓക്കെ റൈറ്റ്. അതിലോ? ഒരു സെക്കൻഡ് അങ്ങോട്ട് പോയിട്ട് ബാ, ഇവിടെ വന്ന് അഡ്മിറ്റ് ചെയ്തോ.
പ്രിൻസിപ്പലൊക്കെ ജോയിൻ ചെയ്തു. എത്ര 14 പേര്.
നീ ഏതാ എടുത്തേ?
Video was interrupted. The streamer stopped the stream.
ഇല്ലല്ലോ.
അത് കട്ടായി പോകുന്നു.
ആ വീണ്ടും വന്നോ? സംസാരിക്കരുത്. Sir has joined. Good evening, sir.
And he said they are not doing any creative work. So please, my request is, please read well, understand well. Whenever you learn a subject, please understand the core of the subject. That's very, very important. And my next request to all my students, you will have to excel, not only in your studies, you will have to excel in your extracurricular activities. I wanted to share a small experience of mine. I was a Fulbright Fellow in the United States, visited 18 universities, 2 schools, and 5 community colleges. When I went to a school, I had the opportunity to interact with some of the students. And, I did not ask any chemistry or physics or nanoscience to them. I asked them, question, how many of you can swim? He said, we all can swim. It was there were 20 students, and how many of you can run a musical instrument? They said, we all can run a musical instrument. How many of you can dance? They all can dance. And you have to be like that. Active, extremely active in all fields. When you leave the school, you have to be an all-rounder. And I also want you to be a person who loves your ecosystem. Don't do any activity which damages our ecosystem. When you go for a shopping, you should carry a cotton bag. Don't buy plastics unnecessarily. And if there is a possibility to support your fellow beings, always you try to help others. That's very important. In a classroom, you will have students of different IQ levels. Please try to support them. I have a very big research group. I'm leading a big research group in Mahatma Gandhi University. 20-25 researchers always work with me for PhD program, postdoc. When I get a new graduate student, PhD student, I always ask my senior students, teach the candidate everything in the laboratory. How to run a microscope, how to run spectroscopy machines. So I always want the students to be very supportive. Don't miss an opportunity to support, to help your fellow beings. And you have to become dignified citizens, obeying our rules of the society. We all know that our country is quite rich with lots of young people. The average age of an Indian person is, according to UN in 2025, is 29 years. That of China is 39, that of United States is 40, that of Japan is 50. You see how the number of young people in the country is something great for the country. So you all have to lead our nation. So I want all the students, they should excel. You all should become dignified citizens and lead our nation. And you all should dream, when you leave the school, you all should dream that you should get into a leading institute in the country. It could be an IIT, it could be ISER, it could be NIT, it could be All India Institute of Medical Sciences, or it could be MIT. You see, a student of mine, a good friend of mine, his son, he went to MIT after his school. He qualified all the tests for MIT and he got into engineering school in MIT. So you should dream. That's what our president always tells us, dare to dream big. So I wish you all the best in your career. I also wanted to say a few words to our teachers. I became a chemist because of my good teachers in school. I used to love my chemistry teacher. I used to act like her, after school. So I was attracted to his chemistry because of her excellent teaching. So I want all the teachers, to be excellent teachers. You prepare well for your class, you motivate the students, you make them enthusiastic, you create the spirit of inquiry, You promote them, ask questions in the class. You have to act as their mentors. You have to act as their instructors. You have to act as their friends. Then you can make wonders. You know, I had excellent teachers in my school, excellent teachers in my college, excellent teachers when I went to Kottayam University, excellent teachers when I went to Indian Institute of Technology. I had excellent teachers. I worked with a professor in Indian Institute of Technology in Kharagpur about 3 years for my PhD program. And I was really surprised the way he was running his life. You know, he used to come at around 8 o'clock in the morning and leaving the laboratory around 10, 10:30, 11. You know, such a fantastic person he was. So I assimilated his way of life. So I'm sure teachers can make wonders. That professor taught me how to write a research article. That professor taught me how to write a good book. That professor taught me how to run an international conference. See, what I'm doing in MGU is all I learned from Professor Sadan Kumar Day from the Indian Institute of Technology. So my message is, teachers can make wonders. I became the Vice Chancellor because of the good training I got from my teachers. I'm always grateful to them. I also want the management to be proactive, be supportive, encourage the students, encourage the teachers. Principal has a pivotal role. Make good infrastructure for the school, get good grant for the school, establish good library, good gymnasium for the school. When I remember I went to a school sometime back in France, in Paris, 300 years old school. I was surprised by seeing the school. You know, they have everything. Fantastic, gallery, classrooms, excellent library, excellent gymkhana, excellent swimming pool. I asked the principal of the school, a priest, I asked him, how do you manage, principal, this sort of infrastructure? He said, this is all from the philanthropist. So principal has a major role, leadership role for the school. And I also want to say something to the parents. I request the parents to listen to the children every day, at least an hour. Understand them, promote them, interact with them. Extremely important. Give them enough freedom to think their own. And they have to decide what do they like. And please promote them. Please promote them to generate critical thinking. That's extremely important. I'm sure the combined action of the teachers, the students, the management, the parents, I'm sure this school, Navodaya school, could be one of the best in the country. And my university will be there for all your support. If you need any help from my side, I'll be there to help you and wish you good luck. Today, the principal and as well as some of your teachers, including Dr. Kurup, asked me to talk about nanomaterials. You know, I'm going to show you very, very preliminary aspects about nanomaterials. Can you all see my slide? The slide.
Yes, sir. Yes, sir.
The title of my presentation is Chemistry of Nanomaterials. I'm going to show you some introductory aspects of nanomaterials. You see, I have an AFM picture here. You see, they're all atoms. Atoms you can see with high resolution microscope, atomic force microscope, transmission electron microscope. You can see atoms. So this, on the left hand side, you have gold nanoparticles. On the right hand side, you can see silver nanoparticles. Extremely fine particles. So my first slide is, I won't take much of your time to give you some glimpses of nanoscience and nanotechnology. What is nanotechnology? What does nanotechnology mean to you? That is my first slide. See, I'm going to show you a very simple example. You can see this is a lotus leaf surface. നിങ്ങൾ എല്ലാവരും ഡെയിലി കാണുന്ന ഒരു കാര്യമാണ് ചേമ്പിൻ്റെ ഇലയിൽ ഇതുപോലെയാണ് വെള്ളം വീണ് കഴിയുമ്പോൾ അവിടെ എങ്ങനെ ഇരിക്കും. Have you ever thought of why the water droplets? Why the water behaves as a droplet rather than forming a film? They cannot form a film. And scientists try to understand. You must have heard about the so-called lotus effect. There is high contact angle between the water and the surface. You all know that, my young students, I'm in the school, you all know that water is hydrophilic. It's a polar material. But the surface of the leaf is extremely hydrophobic. The surface of the leaf doesn't like water. Therefore, water is always forms a droplet. There is high interfacial tension between water and the leaf surface. The scientists wanted to understand this in detail. You know what they did? They examined the leaf surface under electron microscope. Look at this. This is a beautiful cartoon. What you see under electron microscope. The surface of leaf, lotus leaf, has lots of hairy protrusions. Look at this. These are hairy structures. Lots of hairy structures. And these hairy structures are made of wax crystals, nanoparticles of wax. So when you look at the leaf surface, you all may feel that it is a smooth surface. But under electron microscope, high resolution electron microscope, you will find that it has nanoscale roughness. Why this roughness scale? Because of the millions and millions of waxy, hairy structures protruding from the surface. The surface is living in a waxy structures in a protruding, the size is 20 nanometer size. And you can look at this, these are the protrusions and your water droplets. And the very, very high interfacial tension between this water and this waxy crystals. Waxy crystals are 20 nanometer size. Therefore, the water cannot form a film. It always form a droplet. And when there is rain, today evening, you all should look at the leaf surface. These water droplets rolls and get away from the surface. And during this rotation of this droplet, it takes away all the debris. It takes away all the dirt. See how beautifully nature engineered the leaf surface. So this is one of the best examples of nanotechnology. The leaf surface has billions of nanoparticles in the surface. And because of the presence of these nanoparticles, which is extremely hydrophobic, water forms a droplet. It cannot form a film, and it leaves a surface. I want to show you another example. We talk about nanotechnology. Going to tell you the story of നമ്മുടെ പല്ലിയുടെ കഥയാണ് പറയാൻ പോകുന്നത്. ഗേക്കോ അല്ലെങ്കിൽ ഉടുമ്പ് നിങ്ങൾക്കെല്ലാം പരിചയമുള്ള. If you examine, this is a gecko. മലയാളത്തിൽ ഉടുമ്പെന്നാണ്. If you examine the palm of the gecko under electron microscope, you see millions and millions of nanotubes. അതിൻ്റെ പാമിലെല്ലാം ഇങ്ങനെ millions and nanotubes നിൽക്കുക. And because of the nanotubes, ഉടുമ്പിന് ഏത് സർഫസിൽ കൂടെ ഓടി നടക്കാം. നമ്മുടെ കാർന്നോന്മാർ പറയുന്ന ഒരു കാര്യമാണ് ഉടുമ്പിൻ്റെ പിടി. പണ്ട് ഉടുമ്പിനെ ഉപയോഗിച്ചാണ് കള്ളന്മാർ വീടിൻ്റെ മുകളിൽ കയറിക്കൊണ്ടിരുന്നത്. ഉടുമ്പിനെ കയറി ഒരുപാട് പിടിച്ചിരിക്കും. നമുക്ക് വീടിൻ്റെ മുകളിൽ കയറാൻ പറ്റും. You know the reason? Because the palm of the gecko has millions and millions of nanotubes. These nanotubes, these are the nanotubes. These nanotubes are able to stuck to the surface. A surface language pidikin nallava. And that is fantastic. And now in the market, looking at this, in the market you have gecko type adhesive. See? And Spider-Man is actually running around on the roof using this adhesive. The adhesive which Spider-Man nadakunu. Spider-Man doesn't have any special power. He works on the principles of science. He is using gecko type adhesive. And gecko type adhesive is fantastic. So this is a very nice example of nanoscience and nanotechnology. Let me show you another example of nanoscience and nanotechnology. Probably I'll come in the next slide. I will show you. This particular slide really, the history of nanoscience and nanotechnology. How long have nanoparticles have been used? India Parakon nanotechnology. Months, years, or centuries. I would say centuries. This is a centuries old technology. But we understood the science, we understood the chemistry, we understood the physics recently. So it took probably last 30 years, it took almost 30 years for us to understand the physics, chemistry of these nanomaterials. There are fantastic examples in 8th century, 7th century, 6th century. People have used lots of nanostructured materials, devices, pottery using nano-sized particles, chalice used by the Romans. They're all nice examples. Even you look at the Bible, when you read Bible, Exodus 30 to 20, you all must have heard about Moses tried to save the Israelis from Pharaoh's dictatorship. So there was a long journey by Moses. And during this journey, you know what happened? People became very angry with Moses, because there was no food, no water. And people turned away from Moses, turned away from God. You know what people did? They made a golden calf and they wanted to worship the golden calf. And Moses became very angry. The prophet Moses became very angry because the people turned away from God. You know what Moses did? Moses burned this golden calf, dispersed in water, and asked the Israelis to drink. After drinking, they all became all right. They all turned towards God. You know what Moses did? So I would say Moses was the first nanotechnologist. Moses really made nanoparticles by burning gold at high temperature and dispersing water, and asked all the Israelis to drink this nanoparticles of gold water. Probably you all know that gold has a very good action of stabilizing our mind. So I'm posing a question: is Moses the father of nanotechnology? We have fantastic examples in 6th, 7th, 8th, 9th, 10th century. Look at the cathedrals in Europe. If you have a possibility to go to Europe, you look at the cathedral walls, in the glasses. You have fantastic colors on the glasses. They're all because of the nanoparticles. They used nanoparticles for the construction of these glasses. I can tell you another example. In the 6th, 7th, 8th century, the Muslim kings used to win many wars. The big fighters, the Muslim kings. You can see the picture of the war scene, 8th, 7th, or 9th century, and the Muslim kings used to win all the war. And people try to understand why these wars were won by the Muslim kings. You know what they did? They examined the swords, knives of some of these kings. And they found that these swords had beautiful nanoscale material on the edge. ഇതിൻ്റെ എല്ലാ എഡ്ജിൽ ഈ വാളിൻ്റെയൊക്കെ ആ എഡ്ജിൽ beautiful nano knives. During that time, you know what they did? The Muslim kings used to buy iron from India, and they used to do a special heat treatment at very high temperature. And as a result of heat treatment, they used to produce lots of nanowires on the knife. That is why the knife became so sharp. And there's a beautiful paper in Nature about this. Nature 444 to 286. So there are a large number of examples in literature on the use of nano devices nanostructures for a variety of applications. Another example is the chalice used by the Roman priest. Chalice used to show unusual optical effect. Chalice has nanoparticles of gold and silver. I can show you this figure of a chalice. Look at the color of chalice actually changes. Look at the color of the chalice. It changes. When illuminated from outside, it appears green. Now it's green. However, when illuminated from within the cup, it glows red. You see the color changes. Because the presence of nanoparticles. And later, people could synthesize nanoparticles of gold. Look at this. These are all nanoparticles of gold, of varying particle size. See, we have pink gold, we have green gold, we have yellow gold. You see, gold, intrinsic color of gold is yellow. But when you go to nano regime, you have different colors. This is 150 nanometer size. This is 20 nanometer size. So depending on the size of nanoparticles, gold can give rise to different colors. You have pink gold, ruby gold. Let me tell you a little bit about the history of nanotechnology. I will start from the history. The first notable work was from Michael Faraday. Michael Faraday made suspensions of gold nanoparticles and showed to the Royal Society of Chemistry. He showed the Royal Society that I have made nanoparticles of gold. He did not use the word nano. He said we have made colloidal particles of gold. And it was different colors. You can see Transactions of the Philosophical Royal Society, 1857. And then you can see Langmuir got Nobel Prize, and he made monolayers, layers of atoms and molecules, one atom thick he made. The Langmuir Journal of the American Chemical Society commemorating his contribution. Albert Einstein provided thorough theoretical interpretation of the dispersion of gold particles, colloidal particles. And the father of nanoscience and nanotechnology, who is the father of nanoscience and nanotechnology? Richard Feynman from the United States. He got a Nobel Prize, a physicist. And I request all of you to read the fantastic talk by Richard Feynman in 1958. He made a statement, there is plenty of room at the bottom. You know what Richard said? He said there are a lot of opportunity. You can work with atoms and molecules and you can make a variety of hierarchical nanostructures. Got Nobel Prize in 1965. This Japanese gentleman, he used the word nano for the first time. Nanotechnology for the first time from University of Tokyo. And he used the word nano basically to refer to production technology to get the extra high accuracy and ultra fine dimensions. So the term nanotechnology is due to Norio Taniguchi of Tokyo University. There's another major invention, again, Nobel Prize winning work, Gerd Binning and Heinrich Rohrer from the IBM Switzerland. They actually introduced scanning tunneling microscope. With the scanning tunneling microscope, we are able to see atoms. We can play with atoms. We can pick up atoms. A fantastic discovery. And you can see the IBM scientist, Don Eagler. You know what he did? He picked the atom. Don, what he did, with using this scanning tunneling microscope invented by the Nobel Prize winners, he picked up xenon atoms and he wrote the company's name, IBM. So you can play with atoms, you can pick up atoms using atomic force microscope or scanning tunneling microscope. There's another major discovery in nanoscience and nanotechnology, the discovery of fullerenes. Richard Smalley, Robert Curl, and Harald Kracker. can see Harold Kottayam. Kottayam was in our campus for a week. Doctor came to NG University for a week. They shared the Nobel Prize for invention of fullerenes. Then you must have heard the name of Sumino Iijima from Japan. He invented carbon nanotube, another important fascinating material. Quantum dot, invention of quantum dots. People could make quantum dots in the laboratory. A fantastic paper in Journal of American Chemical Society in 1993. Quantum dots were synthesized in the laboratory in 1993. So many inventions came. You know, in 1997, Lucent Technologies fabricated nanotransistor, DNA motor, fuel cells, nanoparticle embedded clothing. Now clothing material is embedded nanoparticle. You have clothing material for soldiers in the warfare. You see, the Canadian soldiers wore the first nano-embedded clothing in the Afghan war. You know, they embedded nanoparticles on their clothing so that some poisonous gases are coming out. This nanoparticle will absorb all the gases, saving the life of the patient. Now you have nanoparticle coated clothes for kitchen, nanoparticle coated clothes for laboratory. So nothing will happen to your clothes, no stain. So this is a very important area, smart clothing, nanoparticle embedded clothing material. Solar cells. Now you see the silicon solar cell that we see used now is very rigid, very heavy, rigid. But now you will be able to have solar cell like this. You can fold like this. You know, very lightweight solar cell using nanotechnology, using plastic film embedded with quantum dots, nanoscale solar cells. There are a large number of nano-engineered products coming out. Now, with this brief introduction, I wanted to tell you what is nanotechnology. Nanotechnology is the ability to work at the molecular level, atom by atom, to create hierarchical structures with functional properties. So you have nanoscale materials for packaging field, nanoscale material for medical applications, nanoscale material for drug delivery, nanoscale material for sensors, nanoscale material for artificial intelligence. So you have nanoscale materials for everything. So you have to assemble atoms and molecules together to make new structures with a fundamentally new molecular organization. That is what is nanotechnology. So nanotechnology is application in electronics, in mobile phones, electronics, in medicine, in industry, in catalysis, in sports, in automotive. Every field nano has a very important role. And you have variety of nanostructures. You see nanoparticles of cadmium sulfide, gold, silver, dendrimers, carbon nanotube, your graphene, nanocellulose. So you have a variety of nanostructures for a large number of applications. I wanted to show you some idea. What is the size nano means? See, if you look at atoms, size is something like 0.1 nanometer. Size of a DNA molecule is 1 nanometer. Size of protein is 10 nanometer. Size of virus is 100 nanometer. And bacteria is very big. Now we are all, facing corona pandemic, coronavirus. What is the size of this virus? In the range of 100 nanometers. That is why we are wearing masks of 2 layers or 3 layers or 4 layers. They are so small they can get in. Size is 100 nanometers. This is to give you some idea of nanoparticle size. Again, I want to show you one more example. The width of a hair is 50,000 nanometers. You see, width of a hair is 50,000 nanometers. Size of the blood cell is 70,000 nanometers. Bacteria is 10,000 nanometers. Virus is 100 nanometers. You see the difference in bacteria and virus. Bacteria is much bigger in size. So this is to give you some understanding of nanoscience, nanomaterials. And I wanted to show you the business opportunity. Some of my students should actually specialize in nanotechnology. Look at the possibility of nanotechnology. Materials and material processing, 340 billion business count. Devices and information technology, IT sector, 300 billion business. Biotechnology, pharmaceutical science, $180 billion business. Chemical manufacturing, catalysis, $100 billion. Aerospace, $70 billion business. Sustainability, water purification, air purification, $45 billion business. Healthcare, diagnostic and prosthetics, $30 billion. So you have lots of business opportunities for nanoscience and nanotechnology. Now I want to show you maybe some important slide where some of the applications of nanoscience. I will skip because of the lack of time. I will skip some of. I will show you some interesting thing we do in our laboratory. I can show you an example. What we have done recently. We work on natural rubber. You all are familiar with the natural rubber. Your rubber research institute is very close to your school. So we work on natural rubber. Look at the behavior of natural rubber. This is pure natural rubber. Pure natural rubber is highly permeable to air. You all must be using, you all must have seen the internal part of a tire. A tire has an inner tube or there's a coating. Tubeless tires have coating. And when you make a tube out of rubber, this rubber should be resistant to escape of air or nitrogen from the tube. So you cannot use natural rubber. Look at this, natural rubber is highly permeating. So you cannot make use of natural rubber to make automotive inner tubes and inner liner because once you pump in, all air will escape. You know what we have done? We introduced nanomaterials into natural rubber. Look at what we have got. This is natural rubber with 5% of fluorohexo white nanomaterial. So natural rubber became highly impermeable to air or nitrogen by putting nanoparticles. So this is some of the work we have done recently. We have showed that you can make fantastic material by nanostructures. Let me show you another work from my laboratory to get you some example. We make nano from agricultural waste. See, these are all nanoparticles we have extracted from agricultural waste, from wheat straw or rice straw. From banana stalk we are able to make nano. From coir fiber we are able to make nano. From pineapple leaf waste we are able to make nano. From crab shell we are able to make nano. From tapioca waste we are able to make nano. So my research group is able to make nanomaterials from agro waste. It's a very important area in my group. See, we work with crab shell. We make nano out of crab shell. I will show you some other examples on this side. A few applications of nanoscience and nanotechnology. You see, automotive, nano is a very important area. Nanoscience and nanotechnology was introduced in the automotive sector by Toyota. You know what Toyota did? They made nylon and nanomaterials together. And they made heat-resistant timing belt for Toyota. This they have done in something in 1985, 86, they have done this discovery. Space transportation, if you look at NASA, they use lots of nanomaterials for their application. Nanosensors, nano electromechanical systems, nanocomposites, nanoelectronics, they do a lot of, you can see the roadmap of nano, also roadmap of NASA. If you look at the roadmap after 2016, they use lots of nanostructured materials. Nano weapons, nanomaterials for manufacturing of weapons, a very, very big area coming in. Surface coating. You look at any of these, if you look at any of the biomedical applications, large number of biomedical applications, plastics are being used. So we give coating of nano on the surface. If you give a nano coating on the surface will not have any crisis. Nanoscale paints, very important. You know, a lot of nanoscale paints. If you paint the surface, you don't have to paint for 20 years. Flame retardant material. Look at this. This is a nano material. It will not burn. Normal polymer is actually this could be decomposed very fast. But look at the nano material, resistant to flame. Biomedical applications, large number of biomedical anti-cancer drugs, targeted drug delivery, implanted insulin pumps, lots of applications for for medicine, nano drugs, medical plastics. All the medical plastics that you get in the market now, they all have nanoscale coating. It could be catheters. For cardiovascular system, they use nanoscale coating. Once you have nanoscale coating, the material gets very good bending stiffness. The extraordinary smooth surface. Once you put something in your body, the surface should be very smooth. It should be resistant to scratch. Sports. Nanomaterial is very important for sports. Look at our tennis ball. I don't know how many of you play tennis ball. You cut open a tennis ball. The inside is nothing but rubber filled with nanomaterial. That is why the tennis ball can rebound very nicely. So it's a very nice example of nanotechnology tennis balls. Tires, look at automotive tires. Now many tire companies, we also work with many tire companies, and inner linings, inner tubes, we make use of nanotechnology. Blouse, nanotechnology is being used. Manufacturing of blouse. TiO2 coated tent. Tent looks extremely clean all the time. This is a TiO2 coated tent. Nano TiO2 coated tent. TiO2 coated, nano coated floor tiles. You see, after 10 years or 5 years, all the floor tiles become very dirty. The color vanishes. A lot of dirt sticks to the your tile, but you give nano coating on the tile, it looks excellent all the time. It looks very neat. TiO2 coated glasses, you know, glass, when you drive an automotive vehicle, if there is rain, the wind glass becomes very hazy. And then you have to use wiper. But if you give a nano coating, look at this. This is actually nano coated windshield. You see, the water falls on the windscreen, and windscreen has a beautiful nano coating which is extremely hydrophobic. So water behaves like as in lotus leaf. Water cannot form a film, so it became a droplet and gets away from the surface. So you have now cars without wipers. The wind glass of the car is coated with nanomaterials. Making fuel go further. All the exhaust of the automotive, you fill with nanoscale materials. Therefore, the fumes coming out from the automotives are clean. Automotive manufacturing, you use nanotechnology quite a lot. But I also want to tell you a few things. Nanotechnology has lots of advantages in medicine, in engineering, in automotive sector, in transportation, in electronics, in computer science. Nano has lots of applications. But we have to handle nanotechnology very carefully. The toxicity aspect is very important. Once nanotechnology is in your body, it cannot be excreted. It will go to your liver. It can go to the brain. So whenever you work with nanoscience and nanotechnology, we have to be very, very cautious. If nano is getting in your, body, you cannot escape the first. So it always remains in your body. So we have to do lots of careful studies, the implication of nanomaterials and toxicity aspects, bioaccumulation. So I put a slide here, is there a risk in nano workplace? I would say there is always a risk in workplace. Whenever I always ask my PhD students, be very careful when you handle nanomaterials. Nanomaterials present new challenges to understanding and predicting, managing potential health risk. Risk as a function of exposure and toxicity. If you are exposed to nanomaterials, if you are inhaling a lot of nanomaterials, very dangerous to your health. And how long you are exposed, how often you are exposed, they are all very important. So we have to do lots of toxicological studies. Understanding this it might take a long time. Now, we are actually finding a vaccine for the coronavirus. So this vaccine will have a lot of side effects. Similarly, nanoparticles also will have a lot of side effects once they are in your body. So we have to be extremely careful. I believe that, in spite of all that, I strongly believe that